This is problem 6-149. It's on page 326. A homeowner is trying to decide between a high-efficiency natural gas furnace with an efficiency of 97% and a ground source heat pump with a coefficient of performance of 3.5, which, by the way, may be a little low for a ground source heat pump, also known as geothermal heating. The unit cost of electricity and natural gas are $0.092 per kilowatt hour, which is 9.2 cents, and $1.42 per therm. Of course, these numbers are a little old. And he makes a note that the therm is 105,500 kilojoules. Determine which system will have a lower energy cost. Well, this is actually not that difficult of a problem. If the coefficient of performance of the geothermal system is 3.5, that's desired output over required input. So we're going to have to pay for electricity, but we will get thermal energy for the home in the amount of Q dot or QH. So basically, this means that the amount of energy we get will be 3.5 times the energy that we paid for. Okay, now that seems like cheating. Well, there's plenty of thermal energy outside for you to take advantage of. That's what heat pumps are all about. In fact, the ground source heat pump pulls that thermal energy from the ground. So that's really nice because the ground maintains an even temperature throughout the year. Of course, the deeper you go, the more consistent it is. The closer to the surface, the more it varies. But another interesting thing is that there's actually a lag in the variations. And as you go down, that lag, that phase shift moves out farther and farther, and that can be an advantage also. Anyway, so the cost for this heat, for the geothermal heat pump, so the cost for the heat for our home from the geothermal system, is $0.092 per kilowatt hour times 1/3.5. In other words, if I'm going to look at the cost, basically for each 1 unit that I pay for, I get 3.5 units of heat. And so all I have to do is pay for 1/3 of the kilowatt hours of heat that I need. That's what I've done here. So when you multiply that out, you find that this is $0.026 per kilowatt hour. Notice that now, since the units of this are energy over energy, in other words, this 3.5 has units, let's invert it again, the 3.5 has units of, well, it's going to be QH over WM. So that would have units of thermal energy over electrical energy. Okay? So that's what we're doing here. We're converting these kilowatt hours of electricity into thermal energy. That's what this 3.5 does. Okay, so this is how much money we pay for each kilowatt hour of thermal energy. Okay? Now let's go for the hot water heater. The hot water heater has an efficiency of 97%. So what is this? Well, this is the amount of thermal energy you get for each, I don't have a good symbol here, so I'm going to use 2. So for each unit of chemical energy that you pay for, you get 97% of that chemical energy into heat for the home. Why wouldn't you get all of it? And by the way, how do you get 3.5 from the heat pump? Well, the reason you don't get all of it is because maybe the fuel doesn't burn completely. Well, today's units are pretty efficient at burning their fuel, but the exhaust gases have to leave. Now, the exhaust gases in a high-efficiency gas furnace are actually really cool. In fact, they're so cool that the water in the air, the steam, starts to condense out. That's why if you have a high-efficiency gas furnace at your home, you'll notice you have a PVC chimney, which is unbelievable because in the old days, you always had to have a steel chimney because the exhaust gases could be hot. And you might melt the PVC, but today you have to have PVC because the water even condenses out to some extent. And water condensing on the inside of a steel chimney is a bad idea because it would rust it out. So anyway, 97% efficiency is really good and is actually practical, believe it or not, for today's high efficiency units. Anyway, the cost, oh, by the way, why is this efficiency, I mean, this looks like 350% efficiency. Why? Where does that come from? Well, it comes from the idea that the amount of energy you get doesn't just come from the power company. The energy you get to heat your home, you're collecting energy from outside and bringing it in. You're pumping up its quality so that it'll keep your house warm. So you're getting some free energy, which is an excellent idea. Anyway, the cost for the same amount of heat, given that we're going to use gas to provide that heat, is $1.42 per therm. But let's go ahead and convert that. 1 therm is 105,500 kilojoules. Okay, so this is dollars per kilojoule. Notice that these kilojoules are already in the form of thermal energy, right? Because if you burn the gas, if you, let me back up. These are already in the form of chemical energy, that's what I meant to say. And once you burn the gas, depending on how efficiently you burn it, or how much of it you get to keep in your system, well, only a fraction of this would be kept. In fact, that fraction is 97%. 0.97 goes in here because all this does, like the coefficient of performance, what it does is it changes the form of energy. This is chemical energy, and this changes it from chemical to thermal, right? Because we only get to keep 97%. Some of it goes out the chimney. Not much, but some. So anyway, finally, to compare apples to apples, let's get rid of these kilojoules in favor of kilowatt hours. So there's 3,600 kilojoules per 1 kilowatt hour. Okay, I understand that this is electrical energy and this is not, right? This is just, well, let me back up. This was electrical energy. This is now thermal energy. This was chemical energy, and this is now thermal energy. So now we're comparing apples to apples. Anyway, the kilojoules go away, and when you plug all this into your calculator, you find that this is about $0.050 per kilowatt hour. Okay, so geothermal is about half the price of even a high efficiency gas furnace, which is really not a surprise. This is actually realistic. I'll tell you something personal. My sister and her husband just bought a home. It's ironic because here I'm the engineer and love geothermal, and that she doesn't really know exactly what it is. She just wants her home to be comfortable. It came with a geothermal heat pump. And so I'm, of course, looking at it and saying, wow, this is neat. You know what this thing does? And she's like, it heats my home for a low price. That's what I know, you know. And she didn't really care. That's not what she's interested in. What she's interested in is the bill, and it's consistently low. They bought a much larger home than their first home, and their heating costs are actually lower in this larger home due to the geothermal heat pump. There are plenty of examples. The Galt House over in Louisville built an addition. You got I don't know if it's east and west. I think it's east and west. And so they're reasonably similar sized buildings, and you can do a nice one-to-one comparison because they're in the same area of the country, so they experience the same temperature and weather conditions and things. Well, this was back in the 80s that they installed a geothermal system. Not only was the system cheaper to install than a conventional system, but they saved $20,000 per month, not per year, not per day, but per month. They saved $20,000, and that's a tremendous savings. So geothermal is a great thing. The reason it's not everywhere is because it costs quite a bit of money to essentially put a heat exchanger in the ground, because all you're really doing is exchanging heat with the ground. In the case of the Galt House system, they're using a well system. And what that means is they drill down into an aquifer and pump up water that's at an average temperature year-round, and you either extract thermal energy from that water or dump thermal energy into that water. And so I'm sure they have some problems with the fact that water from an aquifer like that is going to have a lot of mineral content and things, and I'm sure that, you're going to have trouble with corrosion. But at $20,000 a month, that's a lot of maintenance budget, so it can be practical. Anyway, there are other systems. My sister's system, for example, is a closed-loop system, and so there's literally a heat exchanger in the ground, usually made out of plastic, probably so in her case. And water just circulates through it in the ground and gets either heated up in the wintertime or cooled down in the summertime for heating and cooling respectively. So anyway, I'm a big fan of geothermal systems. I think they're very neat and interesting, and they do save a significant amount of money. The problem is the initial upfront cost.